Debomalya. Mr. Debomalya is currently Assistant General Manager at Lalitpur Power Generation Company Limited, Bajaj Energy group of industry. And he is taking care of many things like railway engineering related construction, track and yard maintenance activities. And regarding his educational qualification, he did his undergraduation, BTech or Bachelor of Engineering, BE in Civil Engineering from Sipu College. Currently, that is known as IEST Sipur. And he was one of my classmates during our BTech days. And he was one of the top 5 students. He was so good. And he finished his BTech with honors. So he's so good, was good so as a student. And after his BTech, he joined a construction company, Adani Group. Then thereafter, Gamon India, then currently Bajaj Group. So within 15 or 17 years of span of time, he now became Assistant General Manager with a good pay package like Dream. So he has such a good expertise in the industry and in managing things. So we are very glad and delighted to have as one of our resource person. So I hope all my participants and faculty members will be privileged and will be benefited from his talk. So, Debomalya, please, you can now start. So
Yeah,
this is
thank you for this introduction. First of all, I would like to thank Janarul and your entire team for organizing such wonderful sessions and for faculty's development program. This is really very good sessions are going on. Actually, due to some busy schedule, I am not able to join all the sessions, but still I can assume, I can understand that all the sessions are going very well and participants are genuinely getting some advantages over it. Okay, so I would start my PPT. Janaru, please, next slide.
Yes.
Yeah. Actually, before starting, I would explain something, the way I have prepared my slides, the presentation. Actually, I have not mentioned in detail bookish expressions, bookish theories in detail, because that will not be that much interesting. Because what I am trying to say today, what I will try to explain is the site-oriented works. Site work, that means project work, execution, and after completion of project, that is after completion of work, operation and maintenance phase. So actually I will explain railway engineering from project and operation and maintenance point of view. So mostly I have prepared these slides based on site photos, some theories, and some snapshots from standard guidelines. Actually, if in railway, we have RDSO standard. Everything in railway is designed or based on RDSO standard. What is RDSO? RDSO is Research, Standard and Development Organization. Its head office is situated at Lucknow. So in railway engineering, whether it is civil engineering, OHE, signaling, in everything, electrical engineering, mechanical engineering, all the things are controlled by RDSO. We have RDSO specifications, drawings, literature, everything is guided by RDSO documents. So here I have shown a standard cross section of broad gauge track. Broad gauge track, we all know, this is where the gauge is 1676 millimeter, 1.676 meter. That is nowadays all the tracks in India is broad gauge. Prior to 2-3 years, meter gauge trains were also there, but nowadays no meter gauge trains run. So all the tracks in India are broad gauge track. This is a standard cross section of broad gauge track for LWR CWR section. What is LWR CWR? LWR is long welded rail or continuous welded rail. Prior to 15 years or 20 years, tracks were jointed with fish plate. Those were fish plated joints. But nowadays, we have welded rails. And in between some standard specified distance, we give some breathing length, some opening. Those may be fish plates or those may be switch expansion joint. Those things I will explain later. So nowadays, generally, we find LWR section or CWR section. So this is a standard rail section, you can say, where we have embankment, top of embankment, that may be in filling or that may be in cutting section. Above embankment, we have ballast section. Here you can see the letter Y. Y dimension is called the ballast cushion. Ballast cushion is above embankment, above subgrade and below sleeper. That depth is called ballast cushion. Okay. Then at the top of ballast cushion, you will have sleeper. Sleeper is having standard length of 2740 mm or 2750 mm. These are all PSC sleepers, pre-stressed concrete sleepers. Then after sleeper, we have additional 305 mm of ballast. Then the side slope of ballast will be maintained as 1 in 1.5. This is also a standard cross slope. And the top width of any embankment standard for single rail, single track will be 7.85 meter. This may be in filling, this may be in cutting. If this is in filling, then beyond the sleeper, beyond the ballast toe, we will have cess of 1 meter. Those details are prescribed in next slide. And in cutting section, additionally, we will have drains. Okay. And the top of ballast section is total length is 3.35 meter. This is standard. Okay, next slide, please. Yeah. In this slide, what is given the dimension of Y, that is ballast cushion. Ballast cushion in general, we adopt 300 mm to 350 mm or in some cases 400 mm. 250 mm is actually nowadays not adopted. Those were adopted in earlier time. But in some yard portion or some old station where modification has not yet been done, there may be 250 mm ballast cushion available. Generally, we adopt 300 mm and 350 mm ballast cushion. That is Y is equal to 250 mm or 300 mm and 355 mm. In some cases, in some important section, suppose you all have heard about DFCC, that is dedicated freight corridor, where heavy traffic movements are considered. There are some stretches also That too, at some stretches, 400 ballast cushion has been considered. Otherwise, 300 to 350 ballast cushion is in general found. According to this ballast cushion, approximate cross-section area of ballast is determined in square meter. These are actually required for reconciliation purpose and billing purpose. Here also, the main thing is for single track, the top of embankment width will be 7850 This is standard. And after ballast cushion, we will have sleeper. Then at two location, that is called rail seat position. Rail seat position, rails will be placed. But in this picture, between sleeper and rail, GRP, that is grooved rubber pads, are not shown. Those will be, I will discuss in later slides. On sleeper, grooved rubber pads are placed. That actually gives smooth riding. That is for comfort riding. Grooved rubber pad is having thickness of 6 mm, 8 mm, 10 mm, or 12 mm, depending upon traffic movement, traffic condition. Generally, 6 to 8 mm thick grooved rubber pads are used. So above sleeper, GRP will be placed, then rail will be placed, and rail will be anchored with sleeper through ERC, that is elastic rail clip. Those detailing can be seen in my other slides where actual rail fittings will be explained. Next slide. Yeah. Here actually double rail has been shown. For single track, I have already mentioned that top width of embankment, either in cutting or filling, will be 7.85 meter. Here, the top width in cutting and filling will be 13.160 meter. That is F, dimension F. And beyond the toe of ballast and up to the extremities of top width of subgrade, that portion is called CES, CESS. CES dimension generally provided with 900 mm to 1 meter, and overall width of cutting section is kept considering the side drains also. Side drains dimension also comes out to be approximately 1.2 meter at either sides. It comes around 11 meter in cutting. In cutting, we have we need greater width because we have to accommodate side drains as well. Okay. And in cutting, we provide side slopes of 1 in 1, that is 45-degree angle. And in embankment filling, the embankment side slope in all the railway embankment, it is standard 1 in 2, that is 1:2 is considered. Again, I am repeating, for embankment in filling, the standard side slope is 1 in 2, that is 1 vertical and 2 horizontal. And in cutting, for normal soils, the cutting profile is considered as 1:1, 45-degree. And in some cases where hard rock or semi-hard rock is encountered, there we can provide vertical cut also, considering slope stability. And in later stages, after 3 year, 4 year, 5 year, is something we can observe. We can observe some decaying of soil during rainy season. We can use different methods for slope stabilization. And at the top of subgrade, we provide 1 in 30 cross slope. That is for drainage purpose. Okay, 1 in 30 cross slope at either direction from center line of the embankment. We have to provide. This is standard. We also provide this cross grade in road embankment also. So this we have to provide. Next slide, please. Yes. This photo actually is at our ongoing project in this Lalitpur Power Generation Company, in my company, where we are constructing new railway track connectivity in cutting section. This is a very deep cut, approximately 9-meter depth from OGL, existing ground level, original ground level. We have gone up to 9-meter depth to construct this cutting profile. We can see two longitudinal drains at either ends. Then cess has been provided 1 meter approximately at both sides. Then our ballast section starts. Okay. And the side slope, as I have already explained that in some portion we encountered hard rock to very hard rock. There we have provided vertical cuts. Otherwise, in soil area, we have provided 1:1 side slope for cutting. Next slide. Yeah. Here I have shown the vertical cut portion at one side. You can see, you can appreciate. And at opposite side, you can see 1:1, that is 45-degree cutting. Because in left side, we encountered hard rock and we kept vertical cutting. We didn't increase our construction cost because cutting, rather blasting, requires huge expenditure. So you can always avoid it by providing vertical cut wherever you encounter hard rock. Yes, and in another, in right hand side picture, what you can see, the crossovers in between tracks. Now, what is crossover? Crossovers are actually the connectivity between two tracks, wherever one track is connected with another track, or one track is divided into 2 or 3 or 4 tracks. These are every time required, as we all know. So here you can see 1, 2, 3, 4, 5, 6 crossovers, and 7, 8 crossovers are not visible here. Now, what consists of crossovers, I will explain in my later slides in detail. Crossover in general actually will consist of tongue rail, stock rail, crossing body portion, lead rail, and CMS crossing. That will overall complete one complete crossover. Okay, I have in detail, I will explain the crossover and parts of it. Here you can also appreciate overhead equipments. Overhead equipments means nowadays most of the track in India, approximately 80 to 82%, 82% of track in India are electrified or on the verge of being completion. Approximately only around 20% tracks are left, but left with OHE, without OHE. That means we need diesel engine. So this OHE work is very important nowadays. Here you can see overhead equipment such as mast, cantilever, bracket, and in right side picture center you can see combined OHE mast, that is portal. Portal is also visible. Portal is that in single portal we can accommodate 2 to 3 tracks. For example, the nearest one, this is a single mast. For single track, single mast is there. And in portal, we can provide connection to, we can adjoin multiple brackets for more than one tracks. Okay, next slide. Yes. This is also the same thing. Cutting profile has been shown. and simultaneously one filling profile. That is, in left side picture at top, you can see one train is moving. That train is moving in embankment filling. That is Indian Railway main track. And in our section, this track is constructed in cutting portion. Okay. And actually, beyond 1.5 kilometer, these two tracks are connected. That connectivity was our main aim, to connect with Indian Railway track. We have provided grids to make up these huge level difference. So simultaneously here, cutting section and filling section has been shown. Okay, next slide. Yeah. Here you can appreciate track is laid on almost at ground level. Here you can see on ground level, we have provided ballast directly. Not much work we had to execute before laying off ballast. We directly laid ballast on prepared subgrade on same ground level almost. Some minor leveling, dressing, cutting was definitely involved. That has to be done to maintain the exact rail level. So those minor works were definitely involved, but majorly you didn't have to cut, and you have not even made embankment filling. Here you can see OHE work is also under progress, where only stringing of catenary and contact wires are completed only, but these are not completed. Checking and adjustments are still balanced. Also, you can see what I was telling, the fasteners of rail with sleeper. Actually, in sleeper, you have 4 inserts where these elastic rail clips insert, and one end of that elastic rail clip lies on flange of rail. By that, the rails are fixed. So in every chainage or every kilometerage on the sleeper, 4 such fasteners are maintained. 4 ERCs are provided. This is the mechanism of rail connection with sleeper. Okay, next slide. Yes. This is embankment filling. Track has been constructed in embankment filling, where we can also see one standard RUB bridge. It's a small bridge. RUB means road under bridge, which is having a standard simple box section, and also has splayed wing wall, straight return wall due to space constraint, and boulder filling for slope protection, as well as inspection steps provided at right hand side. Inspection steps are provided so that track structure can be evaluated, can be seen in regular interval. So for every bridges, we have to provide inspection steps. And at the opposite side of the bridge, we can see height gauge. Structural member height gauge, that is also a very fundamental and important part of any railway bridge, because any vehicle which are allowed to pass through this bridge must be gauged through the size of this opening. That means any vehicle having much higher height cannot enter into this bridge. So there is a barrier that is called height gauge. So this is a standard bridge picture where you can see all the components of RCC box type bridge in case of railway. Okay, next slide. Yes. This what I was saying earlier. This is a turnout. Turnout means a part of crossover. Turnout or point or switch. These three are synonyms, same. Turnout is actually required for connecting two tracks or where one track will be divided to form two tracks. For example, in general, everybody has seen these things. We have up and down main line normally, or somewhere in some part we have multiple lines also, 3 lines or 4 lines. But whenever a station comes, inside a station yard, we find multiple lines, more than 2, more than 3, even 5, 6, 7 lines. So whenever 1 or 2 line will divide to form more than 1 to 3 tracks, there this type of arrangement is required. These are called turnouts or points or switches. Different types of turnouts are there. I have other slides where I will explain in detail the types of turnouts. Here I will explain the parts of turnouts. Okay. Here you can appreciate 4 green colored rails. 4. I think everyone can see. 4 green colored rails. The outer 2 rails are called stock rail. And the inner 2 rails are called tongue rail. So inner 2 rails are tongue rail and outer 2 rails are stock rail. What happens at this condition? You can see at right hand side there is opening between tongue rail and stock rail. And in left hand side, tongue rail and stock rail is not having any gap. So in this condition, if a train comes from our side, that is from the side we are looking at, that flange of the wheel will catch the left hand side tongue rail and right hand side stock rail, and the train will move in straight direction. It will not take the left hand side turnout. Now you see, if this tongue rail changes the position and the right hand side touches the stock rail and we have an opening in left hand side, then the flange will connect with right hand tongue rail and hello
Janalu sir, could you please mute your mic?
Okay. No, the change the slide, the previous slide. Yes. And if the tongue rail changes the position, that means the right hand side tongue rail touches the stock rail and we have a gap in left hand side tongue rail and stock rail, then the train will move towards left hand side. It will bend towards left hand side. It is clear. So what is done here? We have 3 stretcher bars. 3 stretcher bars you can see connected with tongue rails to maintain the gauge. So these stretcher bars will move the tongue rail. Once it will create a gap in right hand side as it is now, and once it will create a gap at left hand side. By doing so, the train will either move in straight direction or in altered direction or bend direction. So this is the mechanism of point and crossing. and for execution purpose, operation purpose, and maintenance purpose, this point zone is the most crucial part. Most crucial part during operation, during maintenance. Nowadays, we have already gone through different accidents in last 2 years, where we have seen that two trains have come in same track. So whenever a train changes its track and which train has to be sent at which track, that is defined by this point and crossing. So any malfunction of this turnout, setting of turnout, that is maybe from signaling point of view, maybe engineering fault, these type of accidents can happen. So construction as well as maintenance point of view, these turnouts are very crucial. Okay, next slide, please.
Sir, sorry for the interruption. If you could unmute your mic, that will be great. Because you are muted, I think. Debomalya sir. Sir, you are muted. If you could unmute yourself. Sir, am I audible? Yes, sir. Now it's
Hello.
okay. Yes, sir. Now it's okay.
So
Okay.
Thank you.
Okay.
Thank you.
next slide.
Okay, next slide, please.
Okay.
Yes, yes. Here I have shown a project phase which is called NI working. That is non-interlock working. This is a very crucial phase of construction activity in any railway project. Actually, for any new railway project, you will have two phases of work. One is new work entirely, which is independent, which you can execute independently. And another is connecting of that new track with any of the existing station, existing yard. Because otherwise, no train will come. You cannot create an independent railway siding without jointing in with any existing railway station or existing railway yard. So whenever you will connect with any existing station or a existing Indian Railway yard, you have to go through NI working. NI working means non-interlocking time, where all the other trains will be operated in manual manner, not through signal, not through point machines. And in those phases, you have to complete the connectivity work. And at those part, civil work, signaling work, and OHE work will continue simultaneously. You can see for OHE work, that is overhead equipment work, electrical work, you can see tower wagon is there. So at the same time, OHE work will be executed. Major civil work, which actually involves a huge number of manpower, that civil work will also be executed, and signaling activity will also be executed. So during that NI work, you have to simultaneously complete all the works. Here I have only shown that NI working where huge number of manpowers are engaged. Okay, next slide, please. Yes. Filling of track ballast. Track ballast is very important part in track structure as far as civil engineering and railway engineering is concerned, because this ballast actually transmits the load of train. Load of train is transmitted to sleeper first through rail, then sleeper distributes transmits the load further to ballast section, entire section of ballast, and then ballast will dissipate further to the prepared subgrade. So ballast section, sufficiency, adequacy, and quality of ballast is very important. Next slide. This is specification of track ballast I have mentioned, which are very important and regularly checked during execution, during maintenance, every time. Checking of quality of track ballast is very important. Now, for everything in railway, I have already mentioned that we have standard RDSO specifications, RDSO guidelines, RDSO literature. So for ballast also, we have to follow only RDSO guidelines. Next slide, please. These are the physical properties of ballast which must be complied. After that only we can use those ballast. Aggregate impact value, we all know. Aggregate abrasion value, we all know. These are the standard limits. Narrow gauge and meter gauge are obsolete, so we only have broad gauge sections. Aggregate abrasion value, maximum we can allow 30%, and aggregate impact value, maximum 20%. Next slide. Yes, water absorption generally 1% and maximum allowable up to 2.5%. Water absorption also plays a very important role. But for ballast checking and quality, aggregate impact value and this gradation. Gradation is very important. Ballast size is the main thing. Its size is between 65 mm to 20 mm. Below 20 mm, only 2% is allowed. If the percentage of ballast goes beyond 2%, finer than 20 mm, beyond 2%, then there will be rate cut. Rate cut on agreed rate. That is the rate what is agreed in PO, purchase order. There will be definitely rate cut if this 20 mm and fine is fined more than 2%. So the main thing is ballast size. We have to ensure it must be between 65 mm to 20 mm. These are the sieve results what we require. Beyond 65 mm, that is more than 65 mm, maximum 5% is allowed. These are desirable. Okay. Next slide. This is frequency of testing at site. What is adopted? This is a standard practice, and these practices are adopted at Indian Railway as well as every private siding railway work. What will be my frequency of testing? Before for that, it is mentioned, first we have to procure 100 cubic meter of ballast and stack it properly. Stack it in trapezoidal section. We all can see those stacked ballast whenever we go through trains. So first of all, we have to construct a trapezoidal section using those 100 cubic meter track ballast. Then from those track ballast, we will first carry out all the tests: aggregate impact value, Los Angeles abrasion, moisture content, and sieve analysis. After that, for if the tests are okay, that means ballast is found okay for use, then further ballast will be procured and larger stacks may be provided, may be constructed, not required to be construct only 100 cubic meter of stack. Stacks may be higher, but sieve analysis, that is gradation test, has to be carried out per 100 cubic meter of ballast. Aggregate impact value and Los Angeles abrasion can be carried out per 200 cubic meter of successive track ballast quantity or any change of source. If a change of source is there, then we have to carry out the tests as I have mentioned earlier. Through initial it will start. You have to stack first 100 cubic meter, then carry out test, and then you can take further tests, gradation per 100 cubic meter and per 2000 cubic meter aggregate abrasion value and Los Angeles aggregate impact value and Los Angeles abrasion. So these are standard ballast quality checking policy. Everybody has to adopt. Okay, next slide. Okay, a case study, that is overview of LPGCL railway yard and track parameters. Here I have taken our yard, but through these track parameters, I will also explain the general general deviations and general features also. So this is not only applicable for our LPGCL yard, but these are also applicable for Indian Railway tracks in different manner. Parameters will vary. Okay, I will explain. Our yard actually consists of 29.5 track kilometer. Okay, total track kilometer is 29.5, and in case of Indian Railway, it's approximately I am forgetting approximately 9 lakh track kilometer approximately, if I am not wrong, because 13 lakh track kilometer is for America is having the longest, then China, then India. Okay, that is a different thing. So there will be a specified track kilometer. So India is having some particular overall track length. Broad gauge track, we all know, meter gauge and narrow gauge are obsolete nowadays. So the gauge is 1676 mm. That is in between two gauge faces. That means the inner faces, the clear distance of inner faces of rail is 1676 mm. Total number of points and crossings, 69. I have already explained that what is the significance of point and crossing and why this number is important. Why this number is important to know that what is my total number of points and crossing, because it will not only affect your construction cost, but it will also affect your maintenance part, because in track maintenance, signal maintenance and OHE maintenance, most focus is kept on point and crossing zone, because these are very critical area. Straight track, normal track is not that much critical. So this I have to know for a particular section. Suppose Howrah to Dhanbad. This is a section. How many points and crossings are there? But maintenance are not carried out in Howrah to Dhanbad section, for example. Maintenance are carried out in further small sections. So I have to know what is the number of points and crossings I have. Based on that number, maintenance gang will be deployed. So this is very important. And we have 1 in 8.5 turnout. Turnouts are mainly 4 types: 1 in 8.5, 1 in 12, 1 in 16, 1 in 20. But 1 in 8.5 and 1 in 12 are most commonly used in nowadays. Indian Railway is having for main lines only 1 in 12 turnout. 1 in 16 and 1 in 20 turnouts are not used because space constraint. To use those turnouts, longer crossover lengths are required, which are very problematic to adopt. So 1 in 12 turnouts are used in Indian Railway main line, and in loop lines 1 in 8.5 turnouts, and in yard portion, private sidings for power plant, for aluminium plant, for iron plant, 1 in 8.5 turnout serves the purpose. So 1 in 8.5 turnout we have used. Total number of bridges 17. Number of bridges is also of a concern because this will also indicate overall project value, and in operation phase overall maintenance value. It will increase because we can all understand bridges definitely has its own expenditure, construction cost, and during maintenance different maintenance activities are involved, and those are critical. Point and crossing and bridge, those are critical part. Among those bridges, 7 are major bridges of composite girder and deck slab, 4 are RUBs, 2 are balancing waterway, balancing canals. All minor bridges are of box type structure. We all know what is box type structure. Balancing waterways are normal type of bridges, what we can find in particular interval. So that one side waterway is not barricaded, is not waterlogged. So in every interval of 2 kilometer or 1 kilometer, depending upon that terrain, that levels of that catchment area, that terrain, in fact, these balancing waterways has to be provided so that one side of water may go to another side of embankment or railway yard. Okay, so these are the types of bridges. Next slide. Our rail is 3 RP. 3 RP means 3 rail panel. In the very beginning of my presentation, I have said that nowadays we do not use fish plate as joints. We continuously weld. But welded joints are a bit expenditure. Those are costlier than fish plated joints. So in yard portion where your permissible speed, allowable speeds are less, there you can use fish plated joints. So in our yard, we have 1 fish plated joint followed by 2 welding, then again 1 fish plated joint followed by 2 weldings in such a way. Here you will not have to provide switch expansion joint for rail elongation and contraction because you have fish plated joints. There you have gap of standard gap of 6 mm. There extension of rail 39-meter long rail because one rail is of 13-meter length. So in 3 rail, that is 3 rail panel, after each 39-meter you are having 1 gap. So that will withstand your rail elongation during summer. At the same time, rail contraction during winter. So this is about our yard. But in Indian Railway, we have LWR, that is long welded rail, 20 rail panel. That means after 20 rail, that is 260 meter, you will have 1 fish plate. Or you may even have CWR, continuous welded rail. That means from one section to one section or from one station to next station, continuously the rails are welded. No gaps are there, no fish plated joints are there. But in those sections, you have to provide ACJ, switch expansion joint, where there is a switch, a type of switch that is called switch expansion joint. There you will have 80 mm opening. Improved ACJ, you have 80 mm of opening that is adjusted, and that takes care of rail expansion and contraction. So for Indian Railway, you have CWR and in some portion LWR, but 3 rail panel is not adopted. For yard portion, 3 rail panel is adopted. At high embankments above 6 meter high and on bridge approaches, you have to provide 1 meter long fish plates. Those are additional features. In Indian Railway also, whenever there is a bridge approach or over the bridges, all the welded joints must be secured with joggled fish plate. Okay, so these are standard safety norms. In our yard, we have 600 long fish plate, but those 600 long fish plates are also obsolete nowadays. You will generally find 1 meter long fish plate. Okay, so in our yard also, some 600 meter long fish plates are also installed, but in every year, as per our budget provision, we are converting the 600 long fish plate with 1 meter long fish plate. We are replacing, because Indian Railway doesn't use 600 long fish plate now. And as I have mentioned, at high embankment and bridge location and bridge approaches, you have to secure your weld joint additionally with joggled fish plates. Those things I will show in my next slides. You can see what is joggle fish plate and everything. Next slide. This is permissible speed. In every section, you will have permissible speeds. For Indian Railway, what is permissible speed? Actually, many people will say 240, 180, 200. No, those are not permissible speeds. Those are speeds of locomotive. And in certain cases, 180 kmph trial has been executed. But today, up to today, maximum allowable speed in Indian Railway is 160 kmph, and that too in a very small stretch from Agra cantonment to New Delhi. That is main route for Chennai, New Delhi, Chennai. That is from New Delhi through Mathura, Agra, Jhansi, Gwalior, Jhansi, Bhopal to Chennai. So this is the main route. This is route C. Here only 200 kilometer long stretch between Agra cantonment and New Delhi is having a maximum allowable speed of 160 kmph. That too for 3 trains only, 2 Vande Bharat and 1 Gatiman Express. That runs at 160 kmph, and rest of the trains are allowed to move at 150. 1 train Bhopal Shatabdi, 1 train New Delhi Mumbai Rajdhani, that is allowed for 140, and the rest of the trains are allowed maximum 130 kmph. So these are the maximum permissible speed of a section. We have for particular section, allowable maximum permissible speed will be nominated, and driver or locomotive pilot will have that sheet on his hand that I am going through this section. This section is having maximum permissible speed of this. Okay, I have crossed this section and entered in the next section. I have maximum permissible speed of this. And at the same time, maximum allowable speed depends on the train also. I have already said only 3 trains are allowed to move at 160 kmph. 2 Vande Bharat in that route, Bhopal to New Delhi, Vande Bharat, Khajuraho to New Delhi, Vande Bharat, and Jhansi to Nizamuddin Express is allowed to move at 160 kmph. Okay, so in our yard, we have different speed restrictions and allowable speeds, what I have mentioned here. Next, you can see sleeper density. Sleeper density is how many number of sleeper I have to erect in particular 1 kilometer. That is very standard number. 1660 per kilometer and 1540. 1660 is adopted for main line and important lines, and 1540 may be adopted at station yards or private siding yards. So slipper density is also very important. As you can understand very well, the more you place the sleepers, more your track will be in its place. So slipper density we cannot reduce. Yeah, if some curves are there, we can definitely increase slipper density, but that's also not required. So slipper density is standard. We are having 1660 per kilometer and 1540 per kilometer. Ballast cushion, in our case, 300 mm, I have already said. It may be maximum 400 mm, 350 mm, 300 mm. 250 mm ballast cushion nowadays is not adopted. Next slide. Next slide. Emergency track repair. Emergency track repair is very important because whenever some failure in track or signaling or OHE occurs, it becomes emergent because trains are continuously running 24 hours a day. So whenever there is a failure, whenever there is any major failure, rather, I would say, train will not be allowed to move. So train will stop. And once the train is stopped, it becomes emergency. So in that way, any major failure in track is an emergency failure which needs to be attended at the earliest. Here you can see one welded joint has fractured. So this fractured railway joint has been secured with joggled fish plate. This is called joggle fish plate arrangement. Joggle fish plate has 2 fish plates, 2 clamp and 2 nut bolt arrangements. This will secure the joint for the time being. And after we complete erection and fixing of these joggle fish plates, we can start railway movement but to a reduced speed. Here, speed restriction will be imposed, but trains will be allowed to move. When the track will be opened for movement at its original speed limit, when this joint will be welded again. Once the joint is re-welded, the original speed limit will be restored. Otherwise, under this circumstance, that is secured with joggle fish plate, you have to carry out train operation under reduced speed restriction. Next slide. Yes, this is same thing. Due to temperature variation, weld joint has fractured, and that also has been restored through fixing of joggle fish plate. Here you can see the P-way fittings, what I was saying earlier. Here you can see the ERC clips, which actually connect the rail with PSC sleepers. These PSC sleepers has inserts. You can see here in one side of sleeper, 2 inserts are visible, and in another side, balance 2 inserts are there. So in here, 2 ERC clips will be used to fix the rail at position. And in between rail, here it is not visible, somewhere it will be visible. I will show you the grooved rubber pads, which are used for riding comfort. Okay, next slide. Yes. Here you can see a fractured fish plate bolt. due to temperature variation, maybe contraction or maybe expansion. Bolt shear is also very normal type of failure. These are not very critical because we have 336 nut bolts. So if one nut bolt is fractured, sheared, train are allowed to move in its original speed. Sectional speed is not reduced. But whenever it is seen, it must be restored at the earliest. We have to replace it with new nut bolt. Okay, next slide. Maintenance of track and track structures. Okay, next slide. Yes. This is IRPWM. In the start, I have already said that whatever work we do in railway, maybe construction or maybe maintenance, this is done as per approved RDSO document. This is also another RDSO approved document, that is Permanent Way Manual. Any type of maintenance activity has to be carried out based on these literatures. So this is a very useful document for all railway maintenance engineers. They have to follow these documents only while carrying out any maintenance activity. Next slide, please. Track tamping machine. Track tamping machine, Indian Railway uses this type of machines for track maintenance work. These machines actually can perform all types of maintenance activities. They can fill ballast deficient area with ballast, number one. Number two, they can square the sleepers. Squaring of sleeper means the sleepers must be in line and at same distance, center to center distance, and squared. So sleeper squaring, number two. Number three, sleeper and ballast packing. So all those activities may be carried out by these machines. Indian Railway has this sort of machines, but for private sidings, track maintenance are generally carried out manually. I will explain that in later slides. Okay, next slide. Responsibility of engineering officials. These are a bit theoretical part. I'm just reading these things, nothing to explain in detail. Devote careful and continuous attention towards the efficient upkeep of track to achieve good and smooth running quality. Running quality should be reviewed by riding on locomotive rear vehicle of fast trains. This is the mechanism followed by Indian Railway. In last one coach is added, which is called moving track recording system is installed, and senior officials can check the track and automatic data, gauge, cross level, longitudinal level, any gauge difference, level difference will be automatically recorded in that van, in that coach. So these are the techniques used to gather site records and to assess where exactly we have to execute track maintenance activity. Okay. Then condition of track is best judged by track recording car, what I have said, in rear wheel track recorder. Oscillograph, these are installed inside the car. And on-foot inspection, trolley inspection, these are also carried out. Trolley inspection is very crucial also. Maintain record of inspection, ensure compliance of inspection. Okay, next slide. I will go through a bit faster here. Classification of track, broad gauge track. Okay. I have already mentioned the speeds. A, B, C are, I will say, A route. Can anyone say? Okay, I am saying A route is dedicated to New Delhi Mumbai route. New Delhi Mumbai via Kota, Ratlam, Baroda. That is A route. B route is New Delhi Howrah. And C route here, it has been mentioned as suburban section of Mumbai, Delhi, Chennai. Okay, C route is actually, or maybe the Indian, the New Delhi to Chennai route via Jhansi, Bhopal. This is actually called C route. So these three routes are very important. And high-speed trains generally move in these three sections, these three routes. And Indian Railway always tries to improve the riding quality and overall facilities to these main routes, A, B, C routes. Okay, next slide. Conventional system of track maintenance, three-tier system of track maintenance, periodical overhauling. After monsoon and before monsoon, detailed track inspection is carried out manually and at the same time through rear wheel inspection car. Those are very, very important. And through sectional gangs, the last point, picking up of slacks, this is done through sectional gangs and sectional patrollers, keymans. These people actually first hand they gather information about track deformities or any problems in tracks. These are done through manual inspection. Okay, next slide. I think I am having less time. Okay, on track machines.
Excuse me, Debomalya, sorry to interrupt you. You have
Okay,
enough
okay.
time. You can continue, please. You want
No,
to-
no. Okay, okay. I will try to finish within my scheduled time.
No,
Not an issue.
If you need
Uh,
15 or 20 minutes more,
okay,
you
okay.
can
If
do.
I need, I will carry out for 10 to 15 minutes more.
Yes, yes, definitely.
Okay, okay. Thank you. So on track machines, these machines actually systematic tamping. What I have shown, that tamping machine, track tamping machine, TTM, intermediate tamping, shoulder ballast cleaning, ballast profiling, redistribution, track stabilization, that is important. Periodic deep screening. Deep screening is replacement of track ballast, complete replacement of track ballast with new one, and at the same time that replaced ballast will be kept at nearby location, that will again be made free from dust, stone dust, which are having lesser than 20 mm size. Those parts will be eliminated and the rest of the ballast will be used again. So this is called screening, periodic screening, deep screening of ballast. Then MMU and sectional gangs. Okay, next slide. Rail cum road vehicle. These are some, actually these techniques are adopted by Indian Railway. Indian Railway is having huge different process of track maintenance and its evaluation, where I have to actually use the gangs to evaluate the exact requirement. These are the methods what Indian Railway monitors. Okay. Creep on gap adjustment, distressing of LWR, CWR. These are also required periodically. Distressing means in case of LWR section or CWR continuous welded rail section, you have to distress the track by once you have to take 1 kilometer of track stretch and you have to open all the track fittings. Then track will be made free. It will adjust its length according to existing temperature. This is called de-stressing of track. If this de-stressing work activity is not carried out at a particular interval or periodically, then there may be deformation of track may be observed. Deformation of track means bending in track. So in time to time, de-stressing of long welded tracks and continuous welded tracks are also important. This is not applicable in our yard track, which is only 3 RP. That is not applicable for our yard. Loading, unloading of material, any other. Okay, next slide, please. Sectional gangs, okay, I have already said these things. Need-based attention to bridges, turnouts, ACJ, approaches of level crossing, greasing of ERC, lubrication of joints, casual changing of rubber pads and other fittings. Yeah, these are also important. These are also actually carried out based on first-hand information received from keyman or patroller. Keyman and patroller carries these track fittings, and wherever required, they change. Okay, next slide. Cleaning of drains, boxing of ballast. Boxing of ballast means ballast profile. In the first slide, that standard ballast section has to be prepared. Ballast tend to roll down with time, with traffic movement. So those roll down ballasts are again made to standard profile. That is called boxing and dressing of ballast. Attention to loop lines, creep and gap adjustment. Gap adjustment is mainly done at fish plated sections. Nowadays, fish plated section is not there. So this is applicable for yard lines only. Pre and post tamping attention. Tamping means that packing of sleeper and ballast. Okay, next slide. These are actually preventive maintenance type. Preventive and regular maintenance. Okay, standard track fittings. Next slide. Yes. Here you can see 1 meter long fish plate with 6 nut bolt, ERC, yellow colored ERC you can appreciate. You can see in one side 2 ERCs are there, and in other side of sleeper 2 ERCs are there. So in every sleeper there are 4 fasteners. Those are called ERC. And if you can zoom, you can appreciate the rubber pads also. Janarul, can you please zoom in if possible? Can you please? Yes. Or zoom in further a bit more. Okay. Now, okay, done. Show the next sleeper. Next sleeper at right side. Next sleeper at right hand side. Yes. Further more. Right side. Yes. Now you can see below that yellow ERC, you can see that rubber pad. Small rubber pad. That is called groove rubber pad. You can have different thickness of rubber pad. In yard lines, only 6 mm thick rubber pad will do. And in dedicated freight corridor, 10 mm or 12 mm thick rubber pads are used. In points and crossing zone, 8 mm rubber pads are used. So these are standard cross section. Janarul, please zoom out. Zoom out. Further, zoom out. In normal photo. Yes. Here you can also appreciate earthing bond that is used for OHE purpose, overhead electrification purpose. These OHE bonds has to be provided whenever you are giving fish plated joints. You have to provide OHE bonds. These are called C joints, C type bond. But in railway yard, railway track, you will not see this type of bonds. You will only see L type of bond, that is bond connecting railway track and OHE mast. Okay. And you can also see one jumper wire, two jumper wires are there. That these jumper wires are connected from one side of rail to another side. Those are used for signaling purpose. Signaling connectivity, those jumper wires are used. Okay, next slide. Yes, this is a 600 long fish plate with 4 bolts. These I have already said that these have become obsolete nowadays. Next slide. Yes, this is weld joint. What I was saying, this is railway, two rails. Yes, yes, yes. Two rails have been jointed with AT weld, aluminothermite weld. I have slides over AT welds also here. So I am not explaining in detail the welding procedure here. You can also see in this peak that is a white colored liner. Janarul, please. The right side. No, 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 right side. This is weld joint. Right hand side. Right hand side. Yes, yes, yes. Here you can see rubber pad, black colored rubber pad and white colored GFN liner. These are called white colored thing is called GFN liner. This is used for signaling purpose to give a discontinuity of current. Okay. Actually, these two rails also act as cables. These rails also carry electric current through these tracks due to signaling work, signaling purpose. So in every slipper, we have to give discontinuity, and these GFN liners are used. GFN liner means glass filled nylon liners. This is also very important fitting. In every slipper, you have to provide 4 ERC, 4 GFN liners, and 2 grooved rubber pads. These are standard fittings for every slipper. In every slipper, you have to provide 4 GFN liner, 4 ERC, and 2 rubber pads beneath 2 rails. Okay, next slide. Yes, welded joint from top view. ERC and GFN liners are visible. And this is a suspended joint. Actually, weld joints should be placed at in between two sleepers. This is standard practice. So welded joints should be suspended joints and should not come on sleeper. Otherwise, stress buildup will be there and weld fracture will be inevitable. Okay, next slide. Annual program of regular track maintenance. I am skipping these things. Okay, the next slide. Gang diary, gang chart, these are required. These are some documents being maintained by gang working team. Okay, next slide. Attention to inspection note, record of work or artisan and other workmen deployed. Half-yearly reports. Okay, these are standard procedures, and SSC to senior DN or DN. What are the responsibilities? It is mentioned here. Okay, next slide. These are actually section registers which are maintained as per para 210 of IRPWM. Okay, I have already explained these things. Next slide. Miscellaneous points, what we have: availability of labor on section, details on encroachment. These are duties of sectional PWI. Any infringement, accidents attributed to PUA, list of reference books. Okay, these are required to be mentioned, these records are required and to be kept for 5 years. This is standard practice. Okay, next slide. Okay, these are some para number, that is specification what we have to refer. Next. Provision of trolley refuge. Trolley refuge is actually for trolley inspection. Regular track inspection is being carried out by trolley, push trolley or motor trolley, and at the same time engine or rear wheel inspection car. So for accommodating push trolley, we have to provide trolley refuge. Trolley refuge means whenever a busy section, in a busy section when trolley inspections are carried out, continuously train moves from one direction. So trolleys, infrequently trolleys has to be kept outside track so that train can pass. So trolley refuge has to be constructed. Trolley refuges are to be constructed. These are the intervals on which trolley refuges are to be constructed. Okay, maximum distance should not be more than 1 kilometer. This is standard practice. In tunnel, inside tunnel, every 100 meter, in either way, you have to provide trolley refuge. High embankment, every 200 meter, you have to provide trolley refuges for keeping the placing the trolleys. Even in bridges also, in major bridges, you will find every alternate pier. On every alternate pier, one trolley refuge has to be considered. Okay, where the trolley man can place their trolley while train moves through the track. Okay, next slide. Manual maintenance of track. Okay, next slide. Through packing, I'm just going through. This is the main activity of track maintenance under manual track maintenance, what we actually adopt in our railway yard, because we do not have machines like Indian Railway, and those are not also required. Through packing is done on program basis after monsoon from one end of the section to other end, generally started on October. This is very important. Time is taken based on seasons, temperature. So after once the monsoon ends and prior to start of winter, this through packing activity is taken out, is started in our yard also and in Indian Railway also. Next page, next slide. Through packing consists of following works being done systematically in the following sequence: opening of road, examination of rail, sleeper fastening, squaring of sleepers wherever required, alignment of track. Alignment of track means actually disalignment, misalignment actually occurs due to sleeper squaring being disturbed. So this sleeper squaring and alignment of track is the same thing. Whenever your sleeper will be squared, aligned, track will become aligned automatically. Okay, next slide. Gauging means actually in ERC and rail flange, there is some gap. That gap is maintained. Those are required due to some other requirements. Those will take more time if I want to explain. So actually what happens, there remains some gap between ERC and rail flange. So sometime gauge may change. Slack gauge may be there, tight gauge may be there. That is more than 1676 mm gauge may be, or maybe less than 1676 mm. So gauge has to be corrected. Packing of sleepers, repacking of joint sleepers. Joint sleepers packing are very important. Joint sleeper is that sleeper where fish plated joint or ACJ is provided, and at the same time welded joint also. Those are important. On those sleepers, packing are generally carried out. Boxing, ballast section and tiding. Okay, next slide. Ballast section is made standard. Under this operation, ballast is opened out. Okay, that is same thing. Ballast section, that is ballast profile, is maintained. Next slide. Examination of rails, sleepers and fasteners. I have already said these are very important. These are noted, these are recorded by patroller and communicated to higher officials, and they time to time will replace the things and change the things. Okay, next slide. Squaring of sleeper. I have already said this is very important. By squaring of sleepers, rail alignment will be corrected automatically. Next slide. Alignment of track. Same thing. The alignment of track is normally checked by eye adjustment mainly. Or if you are having that track, the maintenance machine, that machine automatically does. But for manual maintenance, by eye adjustment, you say the alignment, misalignment of track, and you correct it accordingly. Okay, taking 50 meters of stretch at a time. Slewing is done by about 6%. That is standard requirement. 6 to 8% will be there for each small gang. It will be carried out. Next slide. Gauging gauge tolerance. Gauge tolerance has been shown here. On straight track, -6 to +6 is allowed. On curved portion, -6 to +15 mm is allowed. +6, +15 mm is provided on outer gauge face, that is where the super elevation is provided. The outer face, outer rail, you can provide 50 mm, 15 mm plus gauge, because rail wheel will automatically tend to go towards the outer side. Okay, so these are the tolerances of gauge. Next slide. Packing of sleepers, I have already said. Next slipper, next slide. If you continue, next slide. Next slide. I will go through the point and crossing portion. Next slide, please. These are already I have covered. Next slide. Systematic overhauling. This is done periodically in 5 years. Okay. Of course, obviously depending upon traffic movement. One calculation is done. Calculation is called GMT calculation. Giga metric ton load calculation is there. If total GMT crosses 20, you have to do overhauling, complete overhauling of track. So there are different specifications by which you will do different types of overhauling. What I have told you is for track overhauling, complete track overhauling. For sleeper overhauling, that is changing of sleepers, you can do it by visual inspection. If you find some cracks or some problems, you can change the sleeper. Okay, next slide. Shallow screening, deep screening, I have already said. This is done for ballast, replacing and using some new ballast and reusing some old ballast. This is the technique of reusing some portion of old ballast, and balance you have to add new ballast. This is the technique of screening, shallow screening, deep screening. Okay, next slide. Next slide. Yes, point and crossover. I will explain a bit. I will take some 5 to 10 minutes time. Next slide. Okay, types of turnout. Types of turnout, I have already said, 1 in 8.5, 1 in 12. These are most preferred turnouts. In normal track and Indian Railway is having 1 in 12 turnout. And in yard or in station yard, you can have 1 in 8.5 turnout. You can see crossover length. Crossover length means consisting of 2 turnouts. Total crossover length comes out to be 75 meter for 1 in 8.5. Okay, what is 1 in 8.5, 1 in 12? This is 1 in 8.5 means 1 meter horizontal displacement for every 8.5 meter longitudinal distance. 1 in 12 means 1 meter horizontal displacement of track in every 12 meter longitudinal distance coverage. So it is obvious that in case of 1 in 8.5, the speed limit will be less, and in case of 1 in 12, the speed limit will be higher. While a train is crossing a facing point, in 1 in 8.5, the permissible speed is 15 kmph, and once it crosses a facing point of 1 in 12 turnout, its permissible speed is 35 to 40 kmph. 30 kmph you can definitely have. So 1 in 12 turnout, its length of crossover is more. 107 meter is required for track center. What is track center? That will depend, that will definitely affect the overall crossover length. So this length of crossover is based on two tracks who are having 6.1 meter track center to center. Okay. So this crossover length is calculated based on track center to center. Nowadays, standard track center in Indian Railway is 6.1 meter. You can also find 5.3 meter. You can also find 4.75 meter. But in new project, new line, everywhere you will find 6.1 meter track center to center. Okay, normal switch with stretcher bar. Stretcher bar, I have already said, stretcher bar is connected between two tongue rails, which actually dislocates the tongue rail from one side to another side. So stretcher bars are 3 numbers in case of 1 in 8.5, and in case of 1 in 12 turnout, there will be 4 number of stretcher bar. So another division is normal switch with stretcher bars, and another type of new modern points and crossing are with thick wave switch with SSD, spring setting device instead of stretcher bar. SSD is fixed where the opening of tongue rail is 160 mm. Opening of tongue rail is maintained as 160 mm. So it gives more clearance to incoming track wheel. So this is improved version. Next slide. Yes, here you can see turnout, 2 tongue rail, 2 stock rail, outer 2 are stock rail, inner 2 are tongue rails with stretcher bars. 3 number of stretcher bar is visible, I think. Janarul, can you please zoom a bit where stretcher bars will be visible? I just want to show the stretcher bars. Yes, this first one you can see, appreciate between 2 sleepers. This is stretcher bar and William rod of signaling. This connectivity of in between tongue rails, these iron rods. No, this is tongue rail. This connectivity of 2 tongue rails. Yes, this one. Yes, right. This is called stretcher bar and William rod of signaling. So this type of connectivity, you can see 3 connectivities are there after 2 sleeper, and then again after 2 sleeper. 3 total connectivities are there. Yes, this is the second one, second stretcher bar, and after 2 sleeper, that is the third stretcher bar. So in case of 1 in 8.5 turnout, you will have 3 stretcher bars. In case of 1 in 12 turnout, there will be 4 stretcher bar. And in case of thick wave switch, there will be no stretcher bar. On 13 to 14 sleeper, there will be spring setting device, SSD. Okay, so this is done. This photo is done. Okay. And one thing I have not mentioned, I am just saying, for 1 in 8.5 turnout, there will be total 66 special sleepers or turnout sleepers. Those won't be normal sleepers. Those sleepers will have much more higher length than 2.75 meter. Maximum length of sleeper for turnout sleeper will be 4.65 meter. Okay. So for 1 in 8.5 turnout, there will be 66 number of special sleepers. In case of 1 in 12 turnout, there will be 96 number of special sleepers. Among 96, 5 will be approach sleeper, 83 will be main turnout sleeper, and 448 will be exit sleepers. So 8 exit sleepers, 5 approach sleeper, and 83 main sleeper. In case of 1 in 8.5 turnout, total sleeper will be 67, 5 approach sleeper, 53 main sleeper, and 4 plus 4, 8 exit sleepers. Next slide. Here you can see the crossing body. This in the previous picture, the switch was shown, that is tongue rail stock rail connectivity, and this is a crossing portion, crossing body with check rail, additional check rail. So here actually the wheel crosses one rail. Here actually you will see there at some portion around 1 feet long, that is 300 mm, approximately 300 mm long, where there is no rail connectivity. Okay, hollow portion. The triangle, this is called check rail. So to counter this hollow portion, at both sides check rails are provided. Check rails are the rails, additional 4 meter long rail is provided at both ends of main track. These are check rails. Yes, these are check rails. This is provided because at this wing rail, at the CMS body at the center, there is discontinuity of the tracks. At the center, you can see the discontinuity of the track where the wheel will hang. So the other wheel of the axle needs to be supported. And this support is done by check rail. Okay, next slide. Yes, this is a thick web switch, which is the improved version of 1 in 12 turnout, where the tongue rail is very thick. Janarul, if you can zoom in, I will show the tongue rails are very much thick than normal tongue rail. No, yes, zoom in here, zoom in further. Now you, okay. Now you see the thickness of the tongue rail. Yes. Now just see the thickness of the tongue rail. This is called thick web switch. This is the improved version of 1 in 12 turnout. And in most of the cases, Indian Railway is installing this 1 in 12 turnout with thick web switch nowadays. And you see on that 13th sleeper, that chair plate is installed there. Yes, exactly. At this 13th sleeper, SSD will be connected. Spring setting device will be connected. Because you can see here, no stretcher bar is there. Only through spring setting device, 2 tongue rails will be connected. And here at the tip of tongue rail, that opening is also much more. Here you have 160 mm opening. And in normal tongue rail, you have 120 mm opening. Okay, next slide. I am taking much more time than what I was allowed, what I was allocated.
Please,
Okay, I will
problem.
take further 10 minutes, not more than that. This is thick web switch with SSD. Okay, I have already explained. Go through next slide. This is switch expansion joint, ACJ. What I was telling, that Indian Railway has this ACJ. Our yard also, we also have ACJ. That is, instead of providing fish plated joint where you have continuous welded rail, you have to provide this type of ACJs. This ACJ will accommodate 80 mm of rail expansion. Yes, exactly. At this location, there is 80 mm gap that is visible in top view. In side view, it is not visible. So these type of ACJ will accommodate 80 mm track elongation. These are to be installed 39 meter on either side of any turnout. This is as per specification. We have to install ACJ at 39 point of either side to a point or turnout where there is a continuous welded rail section. Okay, next slide. AT welding process. Next slide. Yes, AT welding process. Actually, before welding, that is jointing of rail, you have to make a gap of 25 mm where newly prepared rail will be inserted. How? I will tell. This is only preparation of gap. Next slide. Here you can see luting has been done. Luting means a shuttering or type of form work, and heating is being done before pouring of mold, before pouring of AT material. This is heating after luting. Okay, next slide. This is heating, and after that iron is being manufactured here. Iron has been manufactured here, and molten iron is falling inside the gap between two rails. Next slide. This is the final step of welding process. Yeah, the next one. Yes, this is after completion of welding, trimming has been done. Trimming means the excess of the material has been trimmed away. Okay, next slide. Next slide. Yes, this is after grinding and finishing. This how it looks after welding joint is completed. Okay, so this is one joint. Okay, next slide. Reconditioning. Next slide. Reconditioning actually is done at the tip of tongue rail where tongue rails are weared out. Okay, after weared out, total length of wear will be 200 mm and depth of wear must be 10 mm. Then you have to repair this tongue rail, tip of tongue rail. Next slide. This welding is being done using H3C weld. Next slide. Then after completing of reconditioning, it is painted with epoxy paint, which will be stored if this tongue rail is not just right now being used. So it will be stored after being epoxy painted. Next slide.
Continue, please.
Next slide. Okay, this is a station building. Next slide.
Yes, please.
Next slide, please. This is panels installed inside station building. Through this panel only, station master operates the points and crossings and signaling system. Okay, this is the panel.
Excuse me, Debomalya.
Yes.
Actually, next speaker is calling me.
Okay, okay.
Asking
Okay,
me
so let's terminate this presentation. I think I have already presented whatever I had to say. So we can conclude the presentation right now.
Yes, I can see. So you are actually wonderful and excellent and outstanding. You are magically covered your real life field experiences to our academic theory and concept through your fabulous and fantastic huge technical railway experience. Debomalya, you are lovely to showcase your railway intelligence and brilliance. And Debomalya, you look like Dada, that Saurav Ganguly. Huh? You look like Saurav
Okay,
Ganguly when
okay.
you are speaking and you're looking at the screen, right? And your voice is like Dada. So it's look like you are leading the railway experience in India. So I'm sorry to interrupt you and stop you.
No, it's okay. It's okay. Actually, I took much more time in explaining some part. Not an issue. And the major part is already over.
Yes, I can see.
Yes.
So participant, please, I will share everything with you. So you can connect with our speaker, expert, Debomalya Rai. You can approach him whenever you necessary for any guide or any suggestion in terms of this railway engineering. Okay, so for now, we have to go for that next session. So Debomalya,
Okay.
sorry, and have a nice day.
No issue, Janarul at all. This is a wonderful experience I also have by connecting with this program.
Faculty,
Okay, thank you.
Okay, thank
And
you,
namaskar,
Debomalya.
namaskar
Thank you
to
very
all.
much from my side also. Thank you very much, sir, Debomalya
Sir, thank you and namaskar. Thank you.
We'll again, General sir has already mentioned that we will look forward to interaction in the future, sir.
Definitely. Why not? Sure.
Thank you, sir. It was a wonderful session. I have attended from the starting to end. So it was very good session.
So Krishna,
Thank you, thank you, thank you.
thank you, Debomalya and Jayanto. Have a nice evening. Bye-bye.
Okay, thank
Bye,
you,
bye,
thank you.
bye, bye. Okay, okay. Janarul, I am leaving because I have some
Yeah,
issues.
yes,
Okay, okay. Thanks,
we'll
thanks.
talk, we'll talk
Thank
about
you, thank you. Okay.
Krishna.
Yes.
Shivsankar Kumar, please, sir. Are you there?
Let me check. Yeah, yes, sir. He's there.
He is there.
Is video on?
Yes, sir.
We are video on.
You are totally like visible. Quite
Yeah,
good.
I'm totally visible. That's good. So my voice is audible there?
Yes, sir.
Oh, that's great. Actually, I am the last, I think, presenter, right?